Good morning, students. Myself, Nagveni, lecturer in Physics, Gangavati Bhagyamma Rural College, Huvinadagali, under the management of Veerashiva Vidyavartaka Sangha, Ballari. In this video, today I have to discuss about the magnetic properties of materials. Okay, this is for BSc 5th semester 6.1 paper syllabus. Under this topic, in the last class, we have already discussed what are the types of magnetic materials and what are those properties. Today I have to discuss the very important theory, that is Lagrange's classical theory of dimagnetism. Dear students, we know that under the dimagnetic materials, what is the relationship, susceptibility and the temperature. We know that the susceptibility is independent of temperature. Okay, now we discuss how the temperature is independent of susceptibility under a theory, Lagrange's classical theory of dimagnetism. See here we will have two figure A and figure B. Consider an electron. We know that the electron is rotating about the nucleus in a circular orbit of radius r. Let m be the mass and E be the charge of the electron. And we know that the electron is revolving around the nucleus. For that purpose, here we should consider, instead of linear velocity, we should consider angular velocity of the electron. And we know that Ze be the charge of the nucleus. When the electron is revolving around the nucleus in a particular orbit, there must be some forces exist. That force we can generally call as the centripetal force. That is, we know the expression for centripetal force, that is F naught equal to mv square divided by r. See here, in this equation, we should write in terms of angular velocity because the electron is revolving around the nucleus in a circular orbit. For that purpose, you should write angular velocity. Therefore, V is equal to, in terms of angular velocity, V is equal to r omega. Now, the centripetal force equal to m r square omega square divided by r. Here, r get cancelled, remaining terms m r omega square. That is equation number A. Now, here the positive charge nucleus and negative charge electron, there must be some forces exist. That force we can call as the electrostatic force of attraction. By using Coulomb's law, we have to write what is the force, electrostatic force of attraction exists between the positively charged nucleus and negatively charged electron. That we know that is F equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. The two charges are Q1 Q2, but here charge of the nucleus is Q1 and charge of the electron is Q2. Now how to apply the centripetal force equal to 1 by 4 pi epsilon naught Ze into E divided by R square. That is nothing but Ze square divided by R square. That is equation number B. Equate these two equations. Equate A and B. Will get m r omega naught square equal to 1 by 4 pi epsilon naught Ze square divided by R square. This is the centripetal force is equal to the electrostatic force of attraction between the nucleus and electron. Now how to simplify? Omega square or omega naught square equal to 1 by 4 pi epsilon naught Ze square divided by mr cube. We want omega naught. Omega naught equal to square root of 1 by 4 pi epsilon naught Ze square divided by mr cube. This we have to consider equation number 1. The magnetic moment of the electron, we have discussed the magnetic moment of the electron is given by m equal to, this is the product of current and area. We know the expression for current. Current is nothing but E omega naught divided by 2 pi into area of the nucleus. Area of the nucleus, that is pi r square. Therefore, the magnetic moment equal to 1 by 2 pi get cancelled, E omega naught r square. This is equation number 2. Next, we have to apply the magnetic field. The magnetic field B is applied with its direction normal to the plane of the paper. In the figure A, observe, when the magnetic field is applied, F is the magnetic field, B is the magnetic field, is applied normal to the direction of the plane of the paper. Then that is as shown in the figure A. Now one more force is acting due to the application of magnetic field. The one more force is acting. That force we can call as the additional force known as Lorentz force FL. Due to the application of magnetic field, when we have to apply the magnetic field to the nucleus, therefore the Lorentz forces exist. Okay, the Lorentz force acts on the electron, and the Lorentz force is given by FL. F suffix L equal to minus E V cross B. V is nothing but R omega. Therefore, minus E in bracket R omega cross B. Therefore, Lorentz force FL equal to minus E B R omega. Now, the condition for stable motion is given by, here there are three types of forces acting between nucleus and electron. One is centripetal force, next electrostatic force of attraction, and third one is Lorentz force. When the condition for stable motion is given by, the centripetal force is equal to resultant of the electrostatic force of attraction and Lorentz force, that is m or omega square equal to Ze square divided by 4 pi epsilon naught r square. Actually here plus, but the Lorentz force FL equal to minus EB r omega, therefore should write minus EB r omega. This is equation number 3. Divide the equation number 3 by MR and rearrange. After rearranging, we will get omega square equal to Ze square divided by 4 pi epsilon naught MR cube minus EB r omega divided by MR. Here RR get cancelled. Okay, remaining is omega square plus EB omega divided by M minus Ze square divided by 4 pi epsilon naught MR cube, that is equal to 0. This is the quadratic equation. This is the quadratic equation. Now we have to simplify or find out the roots, okay, by using Sridhar's formula. Here this is similar to the ax square plus bx plus c equal to 0. Then how to find out the roots? Similarly, here in this equation a equal to 1, b equal to eb divided by m, and c is equal to minus Ze square divided by 4 pi epsilon naught m r cube. We know the formula, b is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. I wrote in the right side. Okay. Now, therefore, after substituting a, b, c value in the above formula, we will get omega equal to minus eb divided by m plus minus square root of e square b square divided by m square plus 4 Ze square divided by 4 pi epsilon naught m r cube. Here we know that the Ze square divided by 4 pi epsilon naught m r cube r square is value is not, r cube value is nothing but omega naught square. In place of this value, how to substitute omega naught square. After that, divided by above equation is divided by 4. After simplification, we will get omega equal to plus or minus omega naught minus eb divided by 2m. How to neglect eb by 2m whole square value. This is very small as compared to the omega naught. Now, therefore, it can be rejected. eb by 2m is very small compared to the omega naught. Therefore, we have to neglect that value. This angular frequency is different from omega naught minus eb divided by 2m. Whatever we will get here, omega equal to plus or minus omega naught minus eb by 2m is different from the angular frequency, that is omega. Okay. This change in angular velocity is called Larmor frequency. Whatever the change in angular velocity is called Larmor frequency. The negative sign shows that here the negative minus EB by 2m negative sign shows that EB by 2m is positive when magnetic field is outward. When the magnetic field, the direction of the magnetic field is outward direction, then that is the value of the B is outside, then EB by 2m is we have to consider as the negative. The magnetic moment due to the Larmor frequency. Here you will get the Larmor frequency. Then due to the Larmor frequency, what is the magnetic moment? The magnetic moment due to the Larmor frequency of electron and induced current. Okay, that is given by magnetic moment M equal to product of current and area. M is equal to product of current and area. Okay. Now we know the value of induced current. In the above equation, induced current I is equal to E omega divided by 2 pi. Okay. In the right side we have to simplify. Omega equal to omega naught minus EB by 2m. Omega naught is very small. They have to neglect the term. Then omega is equal to minus EB divided by 2m. In the above equation, I is equal to E omega by 2 pi. Substitute the value of omega. Therefore, I is equal to E by 2 pi in bracket minus EB divided by 2m. That equal to minus E square B divided by 4 pi m. Next, what is the change in magnetic moment? The change in magnetic moment is nothing but delta M. Delta M equal to induced current into area. We know the value of induced current in the above equation. That is minus E square B divided by 4 pi m into pi r square. Here pi get cancelled. Remaining terms, therefore the change in magnetic moment delta M equal to minus E square B r square divided by 4m. It is not same for all the atom. It varies from atom to atom. Therefore, the induced magnetic moment per atom is given by, what is the induced magnetic moment per atom is delta M equal to minus B E square divided by 4 pi summation of m r square. Now, if capital N be the number of atoms in unit volume, N be the number of atoms in unit volume, then the magnetization M is given by, therefore M equal to minus N B E square by 4m summation r square. Just have to multiply above equation to capital N, number of atoms in unit volume. Then now how to replace r square into 2 by 3 r square. Then you will get capital M equal to minus N B E square by 4m into summation 2 by 3 r square. Therefore, minus N B E square divided by 6m into summation r square. Now, the susceptibility of substance is defined as, the susceptibility of the substance is defined as, it is the ratio of magnetization to the applied magnetic field. The ratio of magnetization, capital M divided by applied magnetic field is B. Therefore, susceptibility equal to capital M divided by H. Now, how to substitute the value of capital M? We get here the value of capital M is minus N B E square r square divided by 6m. Okay. Now, how to substitute the susceptibility? Phi is equal to minus N B E square r square divided by 6mh. And then we have to make the simplification mu naught. Put mu naught equal to B divided by H. Then in place of B by H, have to substitute mu naught. Therefore, the susceptibility equal to minus mu naught capital N E square divided by 6m into r square. Just have to observe this equation. This is the final Lagrange's theory of dimagnetism. Okay. See here in this equation, the susceptibility does not depend upon the any temperature or magnetic field. Therefore, the susceptibility is independent of temperature as well as magnetic field. Okay, this is one of the important property of the diamagnetic materials. In the study of diamagnetic materials, we come to know that when the susceptibility is independent of the temperature as well as magnetic field. Okay, that also we have to prove here. Therefore, there is no temperature term and magnetic field B term in the expression for susceptibility. Therefore, these two terms are independent. Okay, in this video we have to studied about the Lagrange's theory of diamagnetic materials. How the diamagnetic materials are independent of temperature as well as magnetic field for their susceptibility. Okay, in the next video we come to know that what is the expression for paramagnetic materials and also ferromagnetic materials. How the para and ferromagnetic materials are related to susceptibility. Okay, and thank you for watching this video. We will meet in the next video. Thank you one and all.